Hello, my name is Joe Pearson and I am an electronic engineering student at Solent University. I work in an integration and test facility where we undertake various tests and integrations of hardware and software for naval platforms prior to the delivery to the customer or the shipbuilder. Our integrations and test facility is formed of several rigs representative of our customers' platforms that are composed of bespoke and commercial off-the-shelf electronic products such as processing cabinets, IT infrastructure and electrical distributions. There is a need for a rig monitoring system that comes from a few requirements. We desire an understanding of the rig's equipment usage and exposure to events outside of its designed intent, such as overvoltage, overtemp, supply dropouts, etc. We want to be able to provide equipment information to the test engineers, allowing for remote monitoring of the equipment throughout testing and trials, and to provide a holistic supervisory role of equipment to operate safely in absence of the test engineers and the equipment operators, such as for overnight testing or automated testing purposes. From these requirements, an Arduino-based data collection unit utilising a range of analog and digital sensors networked to a LabVIEW-based processor that can provide a user interface via web pages was synthesized. Though my project was ambitious, I was able to demonstrate that the solution has been able to monitor temperature, humidity and power consumption across a range of sensors and chart these measurements to a user interface, as well as to log these events in a text file. This was demonstrated by referencing an external meter or thermometer or sensor against each one of the sensors of the system and show that the system's output was within the stated tolerances for each sensor against the reference measurement. So what were the most interesting parts of my project? I found it was very interesting researching a wide range of sensors and down selecting those that met the project's requirements whilst balancing each of the candidates' pros and cons against one another. Following this, having to undertake experiments and quantifying the behaviours was a very interesting and satisfying experience. For example, the use of a platinum resistance thermometer to interface with the Arduino required understanding the thermometer's characteristics against the desired measurements range, and as well as the input requirements for the Arduino. That meant having a signal processing stage in between, formed of op-amps, to be able to interface to the ADAC on the optimally interface with the ADAC on the Arduino. Additionally, I found working with the current transformers very interesting, being able to measure energy emitted from a power cable and transform this information to provide a wattage output. What did I find most difficult about the project? Though my project was managed via a Gantt chart, fitting the whole project scope in the allotted time was very difficult, especially the software development side, which was large enough to be a standalone project in itself, as this was asking for a data acquisition system that provide discrete logs of each sensor, a graphical user interface, an alarm panel, and as well as satisfying user inputs to silence alarms, reset alarms, set thresholds. It was too much, alongside having to actually research and develop a way of monitoring temperature, humidity, power, and interfacing that all together in a sensible, expandable way. I was very drawn to the development and engineering tasks, such as deriving the equations for the sensor electronics and coding the processor, but very reluctant to focus on the less fun tasks such as producing the drawings and the typing up the reports and the documentation, revising the Gantt chart. If undertaken again, I would definitely break down the project into discrete sub-projects, looking at the sensors and data collection units and the LabVIEW monitoring processor and alarm panels in isolation from one another, rather than attempting to cover them both in a single project, as the amount of unknowns in both of those sort of sub-tasks and the skill dependencies to effectively and efficiently satisfy those requirements were just too much in combination in the given amount of time for the project. So here's an example of the monitoring processor in progress. So this sensor is connected to data collection unit 1 and is connected to analog input 0. Here is the numeric value being represented. This is the threshold and this is the alarm state. If we set the alarm state to below the current value, you get an alarm, and if you set it above it, the alarm disappears. This chart here is connected to this LDR here, which is essentially just a representation of the light in the room as a voltage across this LDR and this resistor. So as you can see, if I get my finger in the way, the resistance goes up and the voltage goes up, such that the ADAC voltage also goes up. I'll take my finger away and it goes down again. This chart here is being driven by one of my digital temperature sensors, which I have nicknamed Blank, which is this one here. So if I start to warm it up with my finger, we should start to see an increase in temperature. And you can see a little notch there. We can also see the numeric readout here increasing as I leave my finger warming up the sensor.